Hello friends, welcome to EC Academy. In this lecture, let us understand convolution in linear time invariant system. So here, we'll understand the concept of convolution sum. Before understanding convolution sum, let us understand some of the key concept in impulse response of LTI system. So this we have understood in our previous lecture. Here h of n represents the impulse response of the system for the input delta of n, which is unit impulse. So we can write the time shifted impulse response as h of n minus k. So this is used in our formula of convolution sum. So if we are having two sequence x of n and h of n, we can write the formula for convolution sum as y of n is equal to summation of k is equal to minus infinity to infinity x of k h of n minus k. So here k represents the index that specifies the range of the sequence which we use. There are different steps for computing convolution sum. First one is folding, which means we need to take a reflect of h of k around k is equal to 0 and we need to obtain h of minus k. So h of n, we can write it as h of k, and for this we need to perform the reflection operation so that we can obtain h of minus k. So here we are performing the time reversal operation, and then we need to shift h of minus k by n units to obtain h of n minus k. We can write x of n as x of k, and we can multiply x of k and h of n minus k. For this, if we perform the summation, finally we will get the output y of n, which will be the summation of x of k into h of n minus k. So here x of k into h of n minus k, we take it as y of k, and for different values of n, we will find different y of k values, and then we will take the summations to get y of n. So graphical representation of this convolution sum can be obtained by plotting x of k and h of k, and we need to perform all these steps and we will get the output. To understand this, let us take an example where we are taking a finite sequence. In this example, first let us take a finite sequence where h of n is given as 1, 2, 1, minus 1. Here, this arrow mark specifies this is the value at the origin, which means at n is equal to 0, we will be having the value as 2, and at n is equal to 1, we are having value as 1, and at n is equal to 2, we are having value as minus 1, and at n is equal to minus 1, we are having the value as 1. In the same way, let us take x of n, which is 1, 2, 3 and 1. So the arrow mark is at 1, which means this is the value at n is equal to 0. This is the value at n is equal to 1. This is the value at n is equal to 2. And this is the value at n is equal to 3. Before solving this problem using graphical analysis, first let us find what is the length of the sequence y of n. As we can observe, the length of h of n is 4 and the length of x of n is also 4. So let us take the length of h1 as L1, which will be equal to 4. Length of the sequence x of n as L2, which will be equal to 4. Therefore, the overall length of the output sequence will be equal to L1 plus L2 minus 1. So the overall length of output sequence will be equal to L is equal to 4 plus 4 minus 1. So the overall length of the output sequence will be equal to 7. So we'll get 7 values at the output. Now we need to know if the length of the output sequence is 7. So what are the values that n can take? So for h of n, the n value is starting from minus 1 to 2, and for x of n, the n value is starting from 0 to 3. So we can say the range of h of n is minus 1 to 2, So n is having this value, and in the sequence x of n, the range is from 0 to 3. So n can have this value. As we can observe, h of n is starting from -1 and x of n is starting from 0. So the first range is starting from -1. Therefore, the output sequence will also start from -1. So here, for example, if h of n is starting from 0 and x of n is also starting from 0, the output sequence will start from 0. So the output sequence will begin from the highest range between these two sequence. The range of output sequence y of n will be from -1, and it will be having 7 values from -1. So it will have the value -1, 0, 1, 2, 3, 4 and 5. So these are the values we need to give for n for our calculation of output sequence. So for these values of n, we'll get the 7 values for output sequence which we need to find. So we know convolution is given by x of n is equal to x of n convoluted with h of n. So to write the mathematical equation, we'll write y of n is equal to summation of k is equal to minus infinity to infinity x of k into h of n minus k. So we can write the formula in one more way. So which means y of n can be written as summation of k is equal to minus infinity to infinity h of k into x of n minus k. For our calculation, we are using this formula. So if you observe this formula, the sequence x of k is kept as it is. Here folding operation as well as a time shift operation is performed on h of k, or we can perform the convolution sum operation by keeping h of k as it is and by performing folding and shifting operation on x of k. So this is the input sequence and this is the response of the system, and we can plot this input sequence and the response as x of k and h of k. So this is the first step you need to do. So x of n, you can plot it as x of k, h of n, you can plot it as h of k. So in x of k, at n is equal to 0, the value is 1, n is equal to 1, it is 2, n is equal to 2, it is 3, and at n is equal to 3, it is 1. In the same way, for h of k, at n is equal to -1, the value is 1, at n is equal to 0, it is 2, n is equal to 1, it is 3, and at n is equal to 2, it is -1. So we have plotted this graphically. For this, we need to perform different operations. Before performing the convolution sum, let us perform the folding operation on h of k to obtain h of minus k. The folding operation, which means the value which is available at -1 will be available at 1. The value at 0 will remain as it is. The value at n is equal to 1 will move to n is equal to -1. The value at n is equal to 2 will move to n is equal to -2. So after performing the operation, we will get this sequence which is h of minus k. Now let us write the standard formula for convolution, which is y of n is equal to summation of k is equal to minus infinity to infinity x of k into h of n minus k. Now let us find the output sequence at n is equal to -1. So to find the output sequence at n is equal to -1, let us substitute n with minus n in this equation. So we'll get y of -1 as summation of k is equal to minus infinity to infinity x of k multiplied with h of -1 minus k. Here already folding operation is done in this sequence. For this sequence, we need to shift the waveform towards left side one position. So here you need to remember, if we are getting negative values for n here, we need to shift the waveform one division left side. So you need to remember, while performing the operation, you need to shift h of minus k towards left side one division because we are having a negative value. So if we get positive value, we need to shift the waveform towards right side one division. So this is for the value of n. Now let us take x of k, that will be multiplied with h of minus 1 minus k. So h of minus 1 minus k is shifting h of minus k one division towards left side. So let us take x of k as it is and let us draw here. This is x of k. Let us draw h of minus 1 minus k. So h of minus 1 minus k is shifting this waveform towards left side one division. So this waveform will begin from minus 3. So at minus 3 we'll be having minus 1. At 2 we are having 1. At minus 1 we are having 2. At 0 we are having 1. So this is the signal after shifting h of k towards left side one division. Now we need to multiply x of k and h of minus 1 minus k. So at minus 3 we are having minus 1 here and here we are having 0. So minus 1 into 0 we will get the value as 0. At minus 2 the value is 1. Here it is 0. So 1 into 0 we will get 0. Now 2 into 0 we will get 0. At n is equal to 0, it is 1 which is multiplied by 1. So it will be 1. So at n is equal to 1, 2 and 3, we are having value as 0 at h of minus 1 minus k. If it is multiplied with this signal, we will get 0 itself. So we will get 0. So if we observe this waveform, we obtained the value 1 after multiplying these two sequence. So we can write y minus 1 of k will be equal to 1. We will get y of minus 1 as 1 itself since we are having only one value. Now let us find at n is equal to 0. The convolution sum formula can be given as y of k is equal to summation of k is equal to minus infinity to infinity x of k into h of n minus k. Since n is equal to 0, we can write it as y of 0 is equal to summation of k is equal to minus infinity to infinity x of k into h of minus k. We have already found the sequence h of minus k. We know the sequence x of k. We need to multiply these two sequence. Now this is the sequence x of k and this is h of minus k. Now we need to multiply these two sequence. So if we multiply these two values with 0, so we'll get 0 itself. So at minus 2 we'll get 0. At minus 1 we'll get 0. At n is equal to 0, it is 2 multiplied with 1. So it will be 2. At n is equal to 1, it is 1 multiplied with 2. So it will be 2. For other values, it will be 0 since it is multiplied with 0. So this is y naught of k, so which is equal to 2 and 2. So we can find y naught of 0, which will be summation of these two values. So it will be equal to 2 plus 2, that is equal to 4. So y of 0 is 4. Now let us find for n is equal to 1. We know y of k is equal to summation of k is equal to minus infinity to infinity x of k h of n minus k. So we can write for n is equal to 1, y of 1 is equal to summation of k is equal to minus infinity to infinity x of k h of 1 minus k. So here we got 1 minus k, which means we got a positive value for n. So whenever you get a positive value, you need to shift the waveform towards right side. So depending upon the value. So since the value is 1, we need to shift the waveform towards right side one division. So h of minus k will be shifted towards right side 1 division, since we got the positive value which is 1. So this is the sequence for x of k. So this is the sequence for h of minus k. We need to shift this sequence towards right side 1 division to get h of 1 minus k. So at minus 1 we will be having minus 1. At 0 we are having the value as 1. At 1 we are having the value as 2. At n is equal to 2 we are having the value as 1. Now if we multiply these two, minus 1 into 0 it will be 0. 1 into 1 it will be 1. 2 into 2 it will be 4. 1 into 3 it will be 3. And 0 into 1 it will be 0. So we got this value which is y1 of k. So y of 1 will be equal to summation of all these values. So it will be 1 plus 4 plus 3, so which is equal to 8. So y of 1 is equal to 8. Now for n is equal to 2, let us find the convolution sum. For n is equal to 2, we will get y of 2 will be equal to summation of k is equal to minus infinity to infinity x of k into h of 2 minus k. Since we are having h of 2 minus k, so h of minus k should be shifted towards right side 2 divisions. So this is x of k, and this is the sequence h of 2 minus k which is obtained after shifting h of minus k 2 divisions towards right side. Now let us multiply these two sequence. At 0, minus 1. At 1, we will get 2. At 2, we will get 6. And at 3, we will get 1. So this is y2 of k. So to get y of 2, we need to take summation of all these values. So y of 2 will be equal to minus 1 plus 2 plus 6 plus 1. So y of 2 is equal to 8. Now for n is equal to 3, we can write y of 3 is equal to summation of k is equal to minus infinity to infinity x of k h of 3 minus k. Now here h of minus k should be shifted towards right side 3 divisions, and it should be multiplied with x of k to obtain y of 3. Now this is the sequence h of 3 minus k, and this is the sequence x of k. So we need to multiply these two sequence to get y3 of k. So if we multiply these two sequence, we will get at 0, we will get 0, since we are multiplying 1 with 0. Then we will get minus 2, then 3, then at n is equal to 3, we will get 2. So we can find y of 3 as summation of all these values, which is minus 2 plus 3 plus 2, which is equal to 3. So y of 3 is equal to 3. For n is equal to 4, we can write y of 4 is equal to summation of k is equal to minus infinity to infinity x of k into h of 4 minus k. So h of k should be shifted 4 divisions right side and multiplied with x of k to obtain y of 4. Now this is the sequence x of k, and this is the sequence h of minus k which is shifted towards right side 4 divisions. So if we multiply these two, we will get at 0, we will get 0. At 1, we will get 0. At 2, we will get minus 3. At 3, we will get 1. And at 4, we will get 0. At 5, we will get 0. So we can write y of 4 is equal to minus 3 plus 1. So which is equal to minus 2. For n is equal to 5, we can write y of 5 will be equal to summation of k is equal to minus infinity to infinity x of k h of 5 minus k. So here we need to shift h of minus k 5 divisions right side. and it should be multiplied with x of k to obtain y of 5. Now this is the sequence h of minus k shifted towards right side 5 division, and this is the sequence x of k. If we multiply these two sequence, for 0, 1 and 2 we will get 0. At 3 we will get minus 1. For 4, 5 and 6 we will get 0. So y of 5 will be equal to minus 1. So we obtained y of minus 1 as 1, y of 0 as 4, y of 1 is 8, y of 2 is 8, y of 3 is 3, y of 4 is minus 2, and y of 5 is minus 1. This is the value of output at n is equal to minus 1. This is at n is equal to 0. This is at n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, and this is the output at n is equal to 5. Let us plot this by writing the output sequence. So we can write y of n is equal to 1, 4, 8, 8, 3, minus 2, minus 1. So here at n is equal to 0, we are having value as 4, which is at the origin. So that's why we can write the arrow mark at 4. So this is the plot of output sequence, which is the convolution sum of the given signal. So here the output is 1, 4, 8, 8, 3, minus 2 and minus 1. So which is plotted at n is equal to minus 1, 0, 1, 2, 3, 4 and 5. Now let us consider example 2, where we are taking the infinite sequence. Here h of n is given as a to the power of n u of n, and x of n is given as u of n. So here u of n is multiplied with a to the power of n. Therefore h of n will be available from n is equal to 0 to infinity, and x of n is u of n, which means x of n will be having the value as 1 from n is equal to 0 to infinity. So we have plotted these waveform for these two sequence. So we can plot h of n as a to the power of n for n value greater than or equal to 0. So n value less than 0, h of n will be equal to 0, since it is multiplied with u of n. Now at n is equal to 0, we'll get h of n is equal to a to the power of 0, which is equal to 1. So at n is equal to 0, h of k is written as 1. So what we are doing, in place of h of n, we are writing h of k. In place of x of n, we are writing x of k. For n is equal to 1, h of n will be equal to a to the power of 1, which is equal to a. And for n is equal to 2, it will be a to the power of 2. So we have written a to the power of 2 at n is equal to 2. At n is equal to 3, it will be a to the power of 3. At n is equal to 4, it will be a to the power of 4, and so on. X of k is u of n, which will be having amplitude as 1 from n is equal to 0 to infinity. So this is x of k. Now we have two conditions for this calculation. First is for n greater than or equal to 0. So for n greater than or equal to 0, both the sequence are non-zero. So that's why h of n minus k is nothing but a to the power of n minus k into u of n minus k. Since x of n is u of n, h of n minus k multiplied with x of n will be left out with only a to the power of n minus k. So that can be used in convolution sum formula, where we will be getting y of n is equal to summation of k is equal to 0 to n. Since both the sequence start from 0 to n, a to the power of n minus k. So this we can write it as a to the power of n plus a to the power of n minus 1 plus and so on up to a to the power of 0. So geometric series formula is there for this sequence, that can be written as 1 minus a to the power of n plus 1 divided by 1 minus a for magnitude of a less than 1. And for n less than 0, we will get y of n as 0. we can take y of n is equal to summation of k is equal to minus infinity to infinity h of k into x of n minus k. So to solve this problem, we have used this formula. So we have kept h of k as it is. We have taken x of minus k, and we'll perform different operation on this, and we'll multiply these two signals. So this is for n is equal to 0. For n is equal to 0, we'll get x of minus k. So if we multiply x of minus k with h of k, so we'll get this as output. So at 0, we'll get amplitude as 1. For other values, it will be 0. For n is equal to 1, we need to shift this sequence towards right side 1 division. So we'll get this sequence. So this x of 1 minus k should be multiplied with h of k. So if we multiply that at 0 and 1, we'll get the values. For other values, we'll get 0. So at 0, we'll get 1, and at 1, we'll get a. For the first calculation, we'll get y of 0, which is equal to 1. For second calculation, we'll get y of 1, which will be equal to 1 plus a. And for n is equal to 2, we need to shift this sequence towards right side 2 divisions. So we'll get this sequence. If we multiply x of 2 minus k with h of k, we'll get this sequence. So we'll get at n is equal to 0, 1, at n is equal to 1, a, and at n is equal to 2, a square. So we can write y of 2 is equal to 1 plus a square. Since it is an infinite sequence, you can calculate this for few steps and you can stop. So this is the plot of y of n. For n is equal to 0, we got 1. For n is equal to 1, we got 1 plus a. For n is equal to 2, we got 1 plus a square. For n is equal to 3, we will get 1 plus a square plus a cube, and so on. So this is the plot of y of n for the given sequence. Now let us understand the properties of convolution. First property is commutative property, where x of n convoluted with h of n can be taken as h of n convoluted with x of n. So this is the commutative property. Associative property, x of n convoluted with h1 of n then convoluted with h2 of n will be equal to x of n convoluted with h1 of n convoluted with h2 of n. So as you can observe here, x of n and h1 of n can be grouped and convoluted, then it is convoluted with h2 of n. It will be same as if we group h1 of n and h2 of n and convolute these two and then convolute with x of n, you will get the same answer. Next is distributive property. So in distributive property, we will take x of n convoluted with h1 of n plus h2 of n. We can write it as x of n convoluted with h1 of n plus x of n convoluted with h2 of n. So these are the properties of convolution sum. This is about convolution sum, problems on convolution, and properties of convolution. Hope you have understood the topic. Thank you.